Welcome back, students. We're going to be talking about APR and EAR today. Now, let me talk a little bit about APR. Now, this is called the annualized percentage rate. You'll also see this called the nominal rate. You may see this, you may have seen this in other problems, but you are going to see this in these problems that we're going to do today. Now, this APR or nominal rate is the rate without considering compounding. We already saw in a previous video how the effects of compounding affect the real rate. Now, the effective annual rate is the rate when you take compounding into consideration. Okay, so we have these two that we're going to be looking at today. All right, so of course, leave me your questions, any time value of money question. I'd be happy to solve it for you. And don't forget, you can download this file and follow along. So a quick overview. The purpose of today is to understand what is the annualized percentage rate versus the effective annual rate. I already gave you a small overview. And understand the impact that different compounding periods have on the effective annual rate. Now, in my lectures, if you're in my class and you're one of my students, I've used the formula. Now, this was before I discovered that the BA2 Plus had a built-in function for EAR. So I'll do the formula for the first couple ones, and then I'm primarily going to use the EAR function in the BA2 Plus. All right? So really quickly, let me talk about what is EAR. I'm going to lecture just a little bit, just a little crash course, right, on what it is. So let's say, for example, we have both of our timelines here, right? And they're each, they're each 1 year. They're each 1 year. And the rate is 12%. Actually, I think I normally label this interest, but that's fine. Probably should be labeling it rate anyways. So we have our present value and we have our future value. Present value, future value. All right, so we have 1 year. Over here we have our annualized. And over here, let's say this is a monthly compounding rate. So let's say that we start our present value with $100 that we're investing. That's why it's a negative, right? Now, we're going to invest this $100 for 1 year at 12%. Without using your calculator, what should we get back after 1 year? I mean, you could use your calculator, right? But if you're going to get 12% in 1 year, you should at this point know that you're going to receive $112, right? Okay, yeah, because that's very simple. Now, when we come over here to monthly, what happens is we go from 1 period to 12 periods because there are 12 months in a year. So we have times 0, we have our 12 month, here we have our 6 month, and then we have, of course, it broken down. So 1, 2, 3, 4. Oh, no, so that's not right. Let me see here. So we have 3, 4, 5. Okay, so 9, 7. Okay, so we have 12 periods here. Now, what happens is, instead of, this is our nominal rate right here. This is our nominal rate, okay? So because this is monthly, each one of these months compounds at 1%. 1% all the way through. Every single month compounds at 1%. So if we start an investment of $100, at the end of the first month we have $101, and then so at the end of the first month, this month here, we have 101, and then that 101 compounds into the next month. So let's use our financial calculator to show how that would work. So I'm going to second clear my time value of money. Now I have 12 periods because it's compounding in months and we're only dealing with 1 year. So 12, the interest rate is 12%, but we have to divide by the number of months in a year, which is 12. So 1%, as I mentioned here. Okay, our present value is that $100 that we're investing, and we have no payments, right? So we're going to compute our future value, 112 and 68 cents. So we would get back here 112 and 68 cents, right? That's exactly what we would get back. Now, you might say, well, what's the big deal, right? It's only $68 more. But let's make this interesting now. Let's say we had $1 million here. So we're going to start off with $1 million as our present value, and we're going to compute our future value. So we would typically get back we would typically get back in interest, right? This I'm getting a little flustered here. If we started off with $1 million, we would get back here 1,120,000. That's exactly what we would get back. However, when we compound by months, we get back 1,126,825. 1,126. Is it 820? 1,825 and 3 cents. 825 and 3 cents. So you can see that this portion here is due to the monthly compounding. So whereas when the yearly rate, right, we only get 120,000 in interest, here we're getting 126. So we get an additional $6,825 just by changing the compounding from 1 year to 12 years. So what does this have to do? I mean, we learned this in the last class. What does this have to do with the effective rate? Well, this tells me that the effective rate over here on the monthly side, the effective annual rate, is actually closer to 12.68%. Okay, now how do we calculate that? Let's use our formula. Now, usually for formulas, I like to use green. At least that's what I tell my students. So the EAR is equal to 1 plus the nominal rate, nominal rate, divided by the number of compounding periods to the power of the compounding periods minus 1. Okay, so let's put this to the test here. EAR is equal to 1 plus the nominal rate is here, 12%. The number of compounding periods is 12 to the power of 12 minus 1. So let's put that into our calculator. I like to do this part of the equation first. So 0.12 divided by 12, okay, plus the 1, okay, to the power, which you can see here, to the power of 12, okay, minus 1. So 1.268, which is exactly what we have up here, 1.268 equal to, actually it's 0.1268, right? But we know that when we convert to a decimal, it's 1.268%. So I always tell my students multiply by 100 if you want to see it in decimal form. Now, one more thing I want to point out. I want to show you how to use above the number 2, you're going to see here ICONV, which I'm assuming is the interest rate conversion. So we're going to do second interest rate conversion, and it's going to ask me, what is the nominal rate? Remember, the nominal rate is the APR, right? It's the yearly rate. So we're going to put in 12, hit enter. We're going to hit down. It's going to ask us for the effective rate. But remember, it says here we can compute the effective rate. So we're going to skip that. And here it's going to ask us how many compounding periods are there per year? Well, there are 12 because we're going to a monthly compounding rate. So we're going to hit enter. And this circles back. But notice this one is now empty. Now we can compute. So notice that the effective annual rate is 12.6825. So this is actually even more accurate because it's going out 4 decimal places. All right, so let's get into the problems here. This should not be too bad. Usually when students see these problems, they're really easy points on the exam, and it's really not that hard to do, right? So let's grab my highlighter. So Fairview Bank offers a savings account that pays a nominal annual interest rate of 4.5%. Nominal annual interest rate, very important. The interest is compounded quarterly, okay? So here comes the question. Calculate the effective annual rate of this savings account. So I'll do this first one using the formula, and then from now on I'll use the function on the calculator. So 1 plus the nominal rate divided by the compounding periods to the power of the compounding periods minus 1. So let's take our figures here. 1 plus, where's the nominal rate? Nominal annual interest rate of 4.5%, but because it needs to be a decimal, 0.045 divided by, this is the compounding periods, compounded quarterly. So that's going to be a 4. That's how many periods are in a quarterly year, to the compounding periods minus 1. I just want to point out, if you haven't seen this before, so yearly is compounding once, and then we have semi-annual, which compounds twice. And then we have quarterly, which compounds 4 times, and then monthly compounds 12 times, okay? Those are generally what you're going to be working with. There are daily and continuous, but for this level of finance, we're just going to leave it at these, okay? So let's put this into our calculator. So I just want to say I like to do this section first, okay? Then I like to add the 1. I like to do to the whatever the power is, and then I'll subtract the 1 here, okay? That's sort of the order that I follow. So let's start with the top of the fraction here, 0.045 divided by 4 plus the 1 to the power, this function here, to the power of 4. Oh, what happened here? I should not get a negative. 0.045 divided by 4 plus 1 to the power of 4 minus 1. So 0.0458, that's the effective annual rate. Again, I'm going to multiply that by 100. Okay, so 0.457, but with rounding, 4.58. Sorry about that. Let's change that. So 4.58%. That's what I would accept on the exam. Now let's use the function here, the second interest rate conversion, and I'm going to clear this second, clear the work. All right, so compounding per year, you can start at any of them. There's no initial one, but compounding per year is 4. So remember to hit enter, otherwise it won't accept it. And then go down, and then the nominal rate is this 4.5. So 4.5. Notice that here it's in decimal places. On the calculator, it's a full number. You got to keep that into account. Okay, enter. And then we're going to go down to our effective rate and hit compute. So 4.5765, which is exactly what we got using the formula. Okay, all right. So now you can use the formula. You can use the calculator. Use whatever you feel comfortable with. Right? Maybe try the formula and then double check with the calculator. Okay, so let's move on to the next problem. Willow Credit Union and Oakwood Bank both offer savings account with different nominal interest rate and compounding periods. So you're trying to decide where to open a new savings account. Willow Credit Union, okay, offers a nominal annual interest rate of 3.75 compounded monthly. And I'm going to use a different color because it's changed. Oakwood Bank offers a nominal annual interest rate of 4% compounded quarterly. Okay. Which bank's savings account has the higher effective annual rate? Okay, so EAR of Oakwood Bank and EAR of Willow Credit. Okay, so what are my two? I'm just going to I'm just going to pull out the two pieces of information I need. So for Willow Credit, my nominal rate is equal to 3.75%, and I'm compounding monthly, which is in 12, and for, oops, sorry about that. And then for, let me see here. Oh, did I get this backwards? Sorry. I must have read them backwards. This is Willow Credit, and this is Oakwood Bank. So Oakwood Bank's nominal rate is going to be 4.0%, and the compounding periods are going to be quarterly compounding. So 4. Okay. All right. Let's put this into our calculator. Let's find out what the effective annual rate is for each of these. Okay. All right. On my financial calculator. Now I'm going to clear the information I have here. It should move them all to 0 except for the compounding per year. So I'm going to start there. So because I don't want to forget that I'm putting in this information. So Willow Credit is monthly, so it's 12 per year, right? And then the nominal rate is 3.75, enter. And then I'm going to calculate the effective rate. I'm going to compute it. So the effective annual rate is 3.82. Or you know what, I'm just going to keep the whole thing. Now 3.8151, just in case it's close. 3.8151%. And now let's do this Oakwood Bank. Let's do second clear. And let's go to the compounding rates per year. So this is quarterly, so it's going to be 4 times a year. Enter. The nominal rate is 4%. And then the effective rate is 4.0604. So 4.0604. And now we can round if we really want to. 3.82 and 4.06. So the effective rate allows us to compare two different terms when they have different compounding periods, okay? We're able to say, okay, definitely Oakwood Bank would pay more effectively even though it's only compounding quarterly, okay? All right, I hope that's clear. Let's keep moving here. So question number 3. So Vanguard Investments offers 3 different bond investment options with the following terms. Bond A, nominal annual interest rate of 5%, compounded monthly. Bond B, nominal annual interest rate of 5.1%, compounded quarterly. And Bond C, nominal annual interest rate of 5%, compounded semi-annually. So I just want to pull this out. So we have monthly, quarterly, and semi-annually. And we have our rates here, right? So this should be pretty easy to put into the calculator. But what is the question? An investor is trying to decide which bond option will provide the highest effective annual rate of return. So which bond option will provide the highest effective annual rate of return? All right, so we now know we can put our information into this function. Don't forget it's second above the 2 is interest conversion. So the nominal, well, let's always start with compounding per year. In this case, it's 12. Enter. The nominal rate is 5.25. Enter, and that means the effective rate is 5.3782. So EAR is 5.3782%. Let's move on to the next one. Second, clear the work. Compounding per year is quarterly, so 4 times. Nominal rate is 5.1. Enter. Effective rate we're going to compute 5.1984. 5.1984. Oops, forgot the 4. 84%. Great. And then let's second clear our work. Go down to the compounding periods. This time it's semi-annually. Semi-annually means twice a year, so 2 per year. Nominal rate is just 5%. And we're going to compute the effective rate, 5.0625. 5.0625%. So which one will provide the highest effective annual rate of return? And that's going to be bond A, right? Remember, the effective annual rate lets us compare across different compounding periods. Okay, let's keep going here. I think there's a total of 5 questions. Yeah, there is. So at this point, it's pretty much very similar. There's not a lot of surprises here. They're pretty straightforward problems. Let's go ahead and go through them. Sunny Bank and Riverside Credit Union both offer 5-year certificates of deposit with the following terms. So nominal interest rate of 4.25, compounded monthly for Sunny Bank, and Riverside Credit Union CD has a nominal annual interest rate of 4.1, compounded quarterly. So this should start sinking in that the more compounding periods we have, the higher the rate's going to be from the nominal rate. So the monthly rate is already higher, 4.25, than the 4.1 at quarterly. So I can tell you right now that Sunny Bank is already higher. But let's see what the question is. Don't forget, we should always read the question. Calculate the effective annual rate for each CD option and determine which bank CD has the highest effective annual rate. Assume the interest rate is reinvested at the respective compounding frequencies. Okay, so this is going to be another straightforward problem, right? So second, clear our work. Let's go to the compounding periods. We have monthly for Sunny Bank, enter, and then nominal rate is 4.25, enter, and then we're going to compute the effective rate, 4.3338. So 4.3338%. And for Riverside Credit Union, second, clear the work. Let's go to the compounding periods of quarterly, enter. Nominal is 4.1, enter, and I'm going to compute 4.1635. 4.1635. Remember, both of these are the effective annual rates. Okay, so of course, because it was already higher and it's monthly, the Sunny Bank CD is going to give us the highest effective annual rate. Okay, all right, let's move on to the last question. So there are 3 local banks offering 5-year certificate deposit accounts with the following terms. So very similar. Bank A has a nominal interest rate of 4.50, compounded monthly. Bank B has a nominal annual interest rate of 4.25, compounded quarterly. And Bank C has a nominal annual interest rate of 4.15, compounded semi-annually. So let me just write monthly is 12 periods, quarterly is 4 periods, and semi-annually is 2 periods. So an investor has $15,000 to invest and wants to determine which 5-year CD option will provide the highest effective annual rate of return. That's not the question, right? Calculate the effective annual rate for each CD option and determine which bank CD has the highest EAR. Assume the interest rate is reinvested at the respective compounding frequencies. So this is no different than the previous problem. Very straightforward. Second, clear any work. Let's start with the first one here. Bank A, compounding periods is 12, enter. The nominal rate is 4.5, enter. And then I'm going to compute the effective rate, 4.5940. 4.44, whoop, what was it? 4.5940. 4.5940%. Okay, this is the effective annual rate for each of these. Okay, so let's second clear our work. Go down to compounding periods, 4 for quarterly, 4, enter. And then the nominal rate is 4.25, enter. Now let's compute the effective rate, 4.3182. 4.3182%. And then lastly, second clear work. Compounding periods is 2. The nominal rate is 4.15. Enter. And then I'm going to compute the effective rate, 4.1931. 4.1931%. So the monthly compounding, so bank A CD is going to be the one that provides us. So we have $15,000. This is where we would want to put it, right? Because it's 4.59% compared to these other two. It's going to give us more at the end of that 5-year term. All right. Okay, guys, I think that's it. Oh, just my quick takeaways. So the nominal rate, or APR, represents the yearly rate without considering compounding. I told you that at the beginning. The effective annual rate is the true yearly rate. And don't forget that the more compounding periods there are, the higher the effective annual rate will be. All right, guys, thanks for sticking through this whole video. I hope you got something out of it. I will see you in the next one.